This tutorial will teach you how to factor a trinomial in order to solve an equation. So before we begin, I want you to pause the video and try this little warm-up challenge. In the middle of the screen, I have 3 diamond patterns. The solutions are these 2 colored numbers in the middle. So what I would like for you to do is see if you can determine, given this part of the diamond pattern, is there somehow you can figure out what numbers the solution will be. Pause the video and give it a try. Okay, let's check to see how you did. Did you notice that in all 3 of the diamond patterns you were given, that they all have a relationship to the number in the top and the number in the bottom? So the relationship is that the number in the top position is their product, and the number in the bottom position is their sum. So if I want to fill in the missing values for this bottom diamond pattern, I'm simply looking for 2 numbers that have a product of 18 but have a sum of 9. So what I'm going to do is I'm going to start listing some factors of 18. 1 and 18, 2 and 9, 3 and 6. Now of all of these possible choices, do any of these pairs also have a sum of 9? Yeah. So our answers are 3 and 6. Did you get that? Well, if you didn't, that's okay because we're going to do a lot of these patterns today. So let's get started. If you're following along in your notes, please write this in the table of contents and then use the appropriate page number. For today's lesson, you'll be able to say that you can solve a trinomial equation that is equal to 0 by using the factoring method. In order to do that, you have to be able to make sure that you can make an equation equal to 0, that you can factor out a GCF, and that you can use the multiplication property of 0 to set up 2 separate equations that are solvable. Alright, I want to talk about this sentence right here. This is a trinomial or polynomial equation, and the letters A, B, and C are simply placeholders. They'll be replaced with some values for the problem that you're given. Oftentimes you might get a problem, let's say, that looks like this. And if I asked you, what is the C value, you should say 5. And if I ask you, what is the B value, you should say 6. And if I ask you, what is the A value, you should say 1. So learning this standard form and learning that A, B, and C are merely placeholders will help you to use the correct numbers when I reference their position. So I might say B, I might say C, and now you'll know where to look to go find that value. Alright, you're going to receive these steps in your notes, so we're going to follow along with them for every problem today. First, we're always going to look to see if we can factor out a GCF. Second, we're going to find a product for the number in the top of our diamond pattern and a sum for the number in our bottom of our diamond pattern. Now the good news is you can make a diamond pattern for every problem by following these rules. The number that you put in the top position has to be the product in the A position and the C position. So you take these 2 numbers, you multiply them together, and that's how you get this number. The number in the bottom of your diamond pattern is simply going to match the number in the B position. That's it. Sounds pretty complicated right now, but you'll say it's pretty easy. You're going to use your diamond pattern to find 2 factors, and those 2 factors are what you're going to use to set up your problem. Let's just get started. Example number 1. Let's solve for x. Right? Now to solve for x usually means to get x by itself. But there's no way to get x by itself if one of them has a power of 2 and one of them has a power of 1. So we can't use properties of equality here. We can't manipulate this sentence in any way using addition or subtraction to isolate the letter x. So what we're going to do is we're going to rename this side of the problem as a product of 2 binomials. And that will give us something that we can solve. So the first thing I want you to do is look at your three terms. Is there a GCF? No. So let's move on to step 2. Create your little diamond pattern problem. So the first thing you do is take the number in the A position, which today will always conveniently be the number 1. Multiply it by the number in the C position. Now this is important. The number in the C position is actually a minus 30. So our value will be negative 30. The next thing we do to find the number in the bottom of our diamond pattern is simply take the B position value. And if you don't see a number, it's a 1. The sign in front of it is very important. So I'm going to put my negative 1 here. And now I'm going to start thinking about what my two solutions are. So something that multiplies to negative 30, but also adds to 1. So I'm thinking about some factors here. 3 and 10, 6 and 5. I think that's all of them. Now, in order to get a product of negative 30, one of my numbers needs to be negative. And in order to get a sum of negative 1, our numbers have to be 1 digit apart. So that looks like this might be my winner. So I know that these two multiply to be a 30, but they don't multiply to become a negative 30. So one of these digits has to be 0. And because our sum is negative, and our sum always has the sign of the larger number, we're always going to make our larger value the negative value. So now it works for our diamond pattern. Seems like a lot of work, but this will get pretty fast for you the more problems you do. The diamond pattern really doesn't have anything to do with our answer, except for the fact that it helped us to pick the numbers we're going to use. So I'm going to set up my left side as a product of two binomials. And the first thing I'm going to do is take my new numbers and put them here at the end of each of those binomials. The first position is reserved for the square root of your first term, and that would be x. So what I just did is I took the expression x squared minus x minus 30 and I renamed it, right? It's kind of like changing 5/10 to 1/2, right? I renamed it so that it was a product of two binomials. And if you're multiplying two things together and the answer is 0, then that means one of these items is 0. We don't know which one. It could be this one is equal to 0, or it could be that one is equal to 0. And this is an example of splitting it up into two separate equations. Now you can show inverse operations here, but I'm betting that most of you will probably skip this blue step because you're pretty fast and you'll know right away that the answers are 6 and 5. Now look at our answers. Sorry, 6 and negative 5. Now look at our two answers. You could put boxes around them. You could even put them in these nice fancy braces. Typically we put them in order from least to greatest. Now, our answers are not the same as our two factors, but they're pretty close. Negative 5 used to be a positive 5. Positive 6 used to be a negative 6. So our answers are always the opposite of our factors. All right, let's try another one. Look for a GCF. Doesn't have one. Create your diamond pattern. The product here. Steal the number from the B position. Well, 5 is prime, so this is going to be fast. Only 1 times 5 makes 5, and 1 plus 5 makes 6. Now, positive 1 and positive 5 are part of my factors. The square root of the x squared term, or the c squared term in this case, square root, is our first term. Set each factor equal to 0. This is important. You can skip the next step, but you should not skip this step. So our solution here is going to be negative 1. Our solution here is going to be negative 5. And if we want to keep it organized, we put them in these fancy braces separated with a comma. Kind of getting the hang of it now? Let's try another one. no GCF, multiply to 64, sum of 16. So let's see, I'm thinking like, 64 is 8 and 8. Oh yeah, that's perfect. So x plus 8 equals 0. Well, these are repeat factors, so I almost don't even have to write it twice, because they're going to have the same answer. And when you have the same answer, you don't repeat it. You just write it once. Did you know that you could also write your answer this way? X plus 8 squared is equal to 0. And did you know that you could take the square root of this whole side because this whole thing is being squared? Right? But if you do that to the left, you got to do that to the right. Now, this is the hard part that kids get confused with. Well, the square and the square root cancel out, leaves me this, but technically there's two answers over here. Not really for us in this case, but if there was some other number besides 0, there would be two solutions. A square root can have a positive root or a negative root. But the good news is that 0 is neither negative nor positive, so we don't have to split it into two. That's why there's only one answer, -8, and that's what we got last time. That's just another interesting method you could use. All right, you want to give this one a try on your own? Look for a GCF. Set up your diamond pattern. Now be careful. Watch your sign. That's a -4 here. I need something that makes a positive 24. So I either need two positive numbers or two negative numbers. And it looks like I have 2 and 12, 8 and 3, 6 and 4. And 1 and 24. But no combination of two negatives, right? Because I have to have a positive answer, but I have to have a negative sum. But none of these are going to sum to -4. Well, it's not very common, but it's possible. For us, this is not factorable. So we're going to write not factorable. Now, that doesn't mean it's not solvable. It can be solved using another method, which you haven't learned yet, but it's not factorable. All right, let's try another one. Notice anything wrong with this one? Yeah, the C term position, right, is on the wrong side of the equal sign. It should be over here on the left with everybody else. So we're going to use an inverse operation and we're going to move it over. X squared minus 10x plus 24. And now we're ready to factor. Product of 24, a sum of -10. Pause this, think about some factors. 1 and 24, 2 and 12, 6 and 10. Now look, you have a negative sum, so that means you need two negative numbers. I know that because this is positive, so I can't have one of each sign. I have to have two negatives. And 6 and 4 are going to work for us. And after I write that, we would split it into two steps. And then any work step after this will be optional. So I'm going to go straight to my solutions. Now, technically, I should probably put the 4 first and the 6 second, but I was just reading from left to right. Alright, I think you got the hang of this, so I want you to pause the video and try these 4 questions on your own. Alright, did you give them a try? Let's take a look at these answers. Pause the video now and really look at all of the work steps. Make sure that you have those down. Alright, let's take a look at something a little more challenging. What's the first step always? It's not the diamond pattern. It's looking for a GCF. And this problem has one. So I'm going to factor out a 5. That leaves me with x squared minus 6x plus 8. And now when I start my diamond pattern, I use these new smaller numbers. So my product is positive 8, but my sum is negative 6. Well, I know I've got 4 and 2, but since the sum is negative, I need 2 negatives. Alright, now watch as I rewrite my factorization. The 5 is still there, but this trinomial turns into 2 separate binomials. Now technically, this is a factor, so I'm going to have 3 separate situations here. The good news is a GCF is never going to be equal to 0, but it is a factor, so you do need to understand that it's part of your solution here. If there was an x out here because there was some kind of variable GCF, that's a whole nother situation, so you got to make sure you're paying attention. But since this is a false statement, it can never be true, then we are going to ignore it. All right? It's important to write it, but it's not part of our solution. Our solution is just going to be positive 4 and positive 2. Right? Remember, your solutions are the opposite of your factors. All right, let's take a look at this one here. First step, GCF. I'm going to pull out a 2. Oh, I need a calculator for this one. 54. Okay. I need a product of negative 54, but positive 3. All right, here's the trick. One of your numbers needs to be negative because the product is negative. Right? So 54 doesn't have that many factors, so I know I've got a 9 and a 6. But since our sum is positive, I'm going to give that negative sign to my lower number because 9 minus 6 is 3. So my factors are positive 9 and negative 6. Now, our GCF is part of our factors, so we're going to write that down, but then we are going to show that it is false, right? X plus 9 is 0, and x minus 6 is 0, and then our 2 possible solutions, and we're done. This isn't so bad. Alright, what's wrong with this one? It's not equal to 0. Now when I move this one over this time, technically I'm going to combine it with this other term. So my new sentence will be 6x squared minus 18x minus 24. Now I pull out my GCF of 6, x squared minus 3x minus 4. Set up my diamond pattern. Find my factors. Choose my signs appropriately. Rewrite my trinomial as 2 separate factors. Set up my 3-way split. And write my 2 solutions. Now I went through that one pretty fast. You might want to pause it and take a look. But I think you're ready to try some on your own. So here's 4 more for you. Pause the video, give them a try. Alright, here are the solutions. Pause the video and look it over. When you're done, I want you to send me an email or a private comment with your answer to this exit ticket. Alright, good luck.